And that way we go. So thanks for joining. So the first one, all right. Steven says, regarding Swarm App 1, have a DB service where I have set a password using Postgres password. Now I want to create the results node service. How do I get this node service to get results from my DB? Swarm App 1. Well, let me refresh my memory on that. Swarm App 1. Okay, so this is the voting app. So how do you get your results from the results? So, okay, so if you look at that example app from Docker doesn't have, you don't specify a bunch of passwords in it, I don't believe, because they hard code everything to just use the defaults, and the defaults with Postgres, I believe, is a blank password, or maybe just, I think it's a blank password. So if you're going to want to customize it, you're going to need to go into the apps themselves and look at what they set for the environment variables and their own. Basically, you're going to have to look at the code of each app, because that app is meant to be very simple as an example. So it doesn't use things like, it doesn't let you set names of other parts of the app or passwords or database names or anything like that. It just uses all the defaults out of the box. So not a great example for security purposes, but it does work easy. So you can focus on the distributed architecture and less on the passwords and naming of things. So long answer there is you'll need to jump in to the code for the result app and make sure that it, I'm not sure what result is running in. I'm not sure, it's a web app. I'm not sure if it's a node app or not, but you'll have to look in the code of that. And that should be in the repo for the example app. If you go to the example app, I'm not sure if there's a link in here to where that example app is at. But if you just look, example voting app, I have the repo myself. If you can't find it, jump in Slack later and ask me for the URL. But you can look at the actual the code inside that image, and then you'll have to build your own custom image. It gets a little complicated, but that's good. That's all of the process of learning this. But that's how you would do that. Hello, Jason, Jeff, Bill. In our environment, the production machines are running a 3.1 kernel. Yeah, 3.10 in Red Hat. Yes. Can you tell me what you're missing out by using a 3.10? So, excellent question, Bill. I always recommend using a 4.x kernel. So, the 3.10 kernel is absolutely the minimum to use Docker, right? Which means that it's over 5 years old. In fact, that kernel that you're using is older than the Docker project itself. And Docker uses all of the kernel functionality. I have seen in production workloads various performance issues with older 3.something kernels. I would recommend, if I was forced to run a 3.something kernel, I would run a 3.17 kernel. It's been years since I've run it in production, but I specifically recall issues around 3.15 that were fixed and 3.17 that fixed other issues. I don't have a list of issues off the top of my head. Docker's official recommendation is anything 3.10 or newer, but the problem I started getting into with projects that we were going to production with was we started hitting issues, whether that was performance-related issues or disk write and I/O issues or something like that, and we never could tell, whether what is that issue going to be related to your kernel, or is it something that's a bug in Docker or in the app itself? And I know that in most of those cases, them going to a 3.17 or newer and generally just a 4.something kernel resolved in almost every case the issues. So if you kind of Google around, eventually you'll land on people saying, I had a performance issue or I had a problem with 3.something and I moved to 4.something and it resolved it. So they don't really know, they didn't really debug to the kernel level. I've also had people come up to me after my conference talks where I recommend 4.something kernels and saying, yes, we too had problems with 3.something kernels. And then we changed them out for a 4.something kernel and that issue went away. So at the end of the day, I'm not really sure I have an accurate list of the specific issues. I'm just going to tell you that if you go to scale in production and you're running dozens of workloads on a single kernel in a bunch of containers, eventually you may have an issue and it's not going to be obvious whether or not it's the kernel, and you're not going to know whether it's the kernel. So if there's anything you can do in your project to get your Red Hat updated to a more modern kernel, do that. It will save you headaches later. I don't think you're going to experience those in small servers where there's a couple of containers in each server. But as you start to drive up the performance and the number of containers, that will probably bite you at some point. I wish I had more information on that, but I just know it's been years now since I've had to deal with anybody on a 3 dot something kernel. This was more like something that I was doing three years ago, something like that. Hello from Spain. Hi, Mello. Um, ooh, Nikish. I think I say it. Nitish. Sorry, I'm butchering some of your names. Oh my goodness, I don't even know what language that is. Hidekai? Feel free to correct me on the pronunciation of these names. Antonis. I've got friends in Greece and North Carolina on the line. Mark Brown. Okay, we got a question. By the way, you have 2 other captains in there. I'll let you figure out who those are. You can go to docker.com/captains, and there are a couple of captains hanging out in the channel. Yeah, Mark, deploying containers on Windows and the app needs to have access to files and deploying containers on Windows and the app needs access to files that end users can update, and the app needs to write out files for external use. Okay, so I always recommend using bind mounts versus volumes. To me, bind mounts are 90% of the time used for local development, because when I start using bind mounts in servers, those become specific host things. In other words, there's something that has to be unique about that host. It has to have files in a specific location. It has to have a host OS mount it somewhere on the OS so that I can get to those files. So I always prefer volumes in a server. If I'm talking about whether it's a dev or test or production box, I'm always going to try to use volumes first. And that way I'm using the volume management commands like the ls and all those other commands you get with the volumes. Use volumes plugins. You can get those in the store or just Googling around for volume plugins. That way you have Docker aware and managing those connections. And usually if you're in a multi-server swarm or something like that, you're going to need some sort of third-party volume driver like Rexray to manage your shared storage. If I just can't get the volumes to work right for some reason and I need very, very granular control, I might use a bind mount. But usually nowadays, between the third-party drivers and the way that volumes works, I'm always going to prefer that volume abstraction versus a bind mount, which is sort of a hard-coded, only on this node kind of setting. Anyway, there's nothing inherently bad with bind mounts. They function the same way in terms of the disk I/O and stuff as a volume. It's just by using a bind mount, you're removing the volume management abstraction, and you lose that feature set, and I don't like to do that. All right. Knight says, I tried to use Docker's automated script to add their repository and install all the dependencies with command line. I'm instructed, but it looks like C is no longer supported on. Okay, CE was never really supported on RHEL. Okay, so I'm not sure if this question is about what's supported on RHEL or. Oh, okay. You're using Docker. Okay, so with RHEL, you can't use Docker's automated script. The get.docker.com, I think, is what you're talking about. So that script that you can use to download and install Docker automatically, that I only recommend. Well, that only works on supported OSs. And the way that Docker's attitude around what supported OSs are is that basically CE, Docker CE, is the free edition of Docker. And if it's going to be on a free OS, you can get free Docker. If it's a paid OS, you have to use paid Docker. So a paid OS would be like Windows Server 2016, which uses Docker EE. It just happens to come with its own license of that. RHEL, there's a couple of other Linux variants, not CentOS. I'm thinking of, I can't think of the name of all of them. There's one out of Germany. Anyway, those paid Linux OSs, you are supposed to use Docker EE. You can figure out how to use Docker CE by using, for example, with Red Hat Enterprise Linux, it's basically the same package manager and compatibility as CentOS. So go look up the CentOS instructions. Here's the long answer to your question. Go look up the CentOS instructions for Docker and use those same instructions to install it on RHEL. That'll get you the CE version build that will work in Enterprise Linux. You still have to have the latest RHEL. I think 7.3 or newer is what you're going to need to use there. 6 isn't supported, and I'm not even sure if 7.0 is supported anymore. But that will get you working. Let's see. Okay, so Arjun, on your question about Kinesis and CloudWatch, I don't know. I don't know that tool. So there's 2 ways you can really deal with logs on a Docker server if you're talking about production, and it sounds like you are. So you're talking about getting the logs off the server. You can use a logging driver, and there's a bunch built in, right? So if I just did Docker logs, and it sounds like you know all this, right? Actually, if I do a Docker info, yeah, so you get all these Docker log drivers out of the box. So you can do that, and you can configure that either for the whole host or for each container you run. You probably have been using that for the CloudWatch driver. And then, because there's an AWS logs driver there, if you can see that. And the other way is to just dump the logs into the standard JSON file that's on the system, or maybe to dump it to syslog on the system, and then to use some other container on that host to process and get those logs into whatever your tool is. So if you don't have a logging driver built in that has all the features and functionality that you want, the next best way is to have, like, you could have a global service in a swarm that does the proper bind mounting of wherever the logs are on the host, and then processes those and then shoots them to wherever you want. There's third-party driver tools that will do that, and that is probably a longer discussion than I want to go into, but let me see if I can pull up a couple for you. And I don't know which ones specifically are going to work. If anyone else knows in chat about that, they can always reply to you. But I'm going to pull this one over real quick. FluentD is one. And FluentD is basically, if you haven't checked out FluentD, it's basically a middleman that sits between your Docker, any logs, and then anything else you want to put them to. And it just processes them and gets them to where you need to go. So you can have like any logs coming in and then process them. And FluentD can run in a container and then have it shoot to wherever you need to go. That it's sort of a multi-purpose tool for processing logs, so you can check that out. It's not the only one out there. There are other ones. If people have used other ones similar to that, I would recommend just throwing them in chat to help them out. Hopefully that will get you there. All right. So, Kyuagi, reading your question. If I want to put an app in a container that routes its networking through a specific proxy server, would it make more sense to bundle the proxy with the app or use 2 different containers? All right, so in that case, what I would say is routes its networking through a specific proxy server. So it depends on if you're talking about outbound egress connections or you're talking about ingress connections that are coming in like through a reverse proxy. So if it's a reverse proxy, I would say it depends on the application, how that application functions. If you're talking about a software proxy, whether it's outbound or inbound, I would probably try to put that as a secondary container and not try to bundle them together if that's what you're asking. If it's something, the only exception I have to bundling multiple apps, especially like a proxy inside the same container, are with PHP and Cold Fusion, if you happen to use those languages. PHP and Cold Fusion basically function the same way with Nginx or Apache, where you have to have this web server in front of the application to make them work together, and there's a one-to-one relationship there. And whenever you deploy another PHP server, you deploy an Nginx with it using PHP FPM. In those cases, I go against the Docker best practices and I bundle them in the same container. And I use a simple init. You can actually look on Docker documentation about how to run a multi-binary container that runs multiple services at the same time. They have that in the docs, an example. It's a pretty simple example that works really great. And that in that case, I would bundle them both in the same container. That way it's easier to deploy, easier to manage. But in most cases, I would always have it as a separate container, probably in the same swarm. If you're talking about outgoing connections, that's going to be a more complex topic about how your network is architected and how you're going to get connections out. For example, if you have a web proxy in a data center that proxies all outbound connections, that is usually something handled by a network device or a network team. So if you have more questions on that, I'll just ask them in the chat, and I'll get to them as soon as I get down the list here. All right, I got an application running inside a container with Postgres embedded inside the application. So if a container crashes on the run, will the data be persistent in the container? Okay, yeah. First off, if you have an application running in a container with Postgres, I would do everything I can to abstract those two out, because now you're making a really complicated application. You're basically losing a lot of benefits of containerization. If you're bundling them together, now you have to manage the Postgres install yourself. You can't use an official image. You have to make a really custom image. So there's no real benefit that I can't. It's hard to imagine a scenario where you're going to benefit from having those in the same container. Ideally, you should have those two separate containers using like an official Postgres image that you can even customize, but you're basing it on an official image, and then your app runs in a separate container. And then if you need to deploy it, you're using a compose file usually. You can use that with the standard Docker compose locally. You can use that with Swarm. You can actually now, if you have Kubernetes on the back end, you can actually use compose with that and use the Docker CLI to deploy it that way, or just use a Kubernetes services file. That way you're doing the best practices of splitting that stuff out. If you absolutely cannot get around that and someone's forcing you to put these bundle into the same image, you would have to use volumes. The same rule applies. If you're using a volume with a persistent data Postgres standard image, you would want a volume inside that same image so that when that application crashes and it restarts it, that the data is coming back up. But that's the problem with that container, right? The minute that application in that container has a problem, that container is going to be replaced in most orchestrators. And so that's going to crash your database, because now the application and the database are running together, versus if they were split, the database would be up and stable and the application can be updated and replaced without messing with the database. That's one of the other benefits where you can separate those out and get that level of abstraction. So if you can't separate them out, use volumes. Always use volumes. And the best way to do that is put it in the Docker file. That way, even if you forget or someone's playing with it and they forget, the volume is always used to store that data for your database. Christopher, I have just recently enrolled in your Udemy course. I was wondering, should I start learning Docker? I have basic front-end and back-end knowledge. So yes, you should use Docker. Of course, I'm a Docker fan. I used in my own web startup. That's how I got started with Docker 4 years ago. I would definitely recommend that. The reason being is that once you build your app in that container and you design it to run inside an image, it makes your CI easier, it makes your deployments easier, and then it makes updating your app in production easier. That whole workflow gets easier. And it also means that if you build another type of app, they all work the same way when you deploy them. You don't have to have a web front-end app that has a custom deploy script, and then you have some database backend that has a totally different script. You don't have to worry about that, because Docker makes a lot of that consistent. So absolutely take at least the first half of my Docker Mastery course. Thanks for buying it. And then you'll see sort of some of the benefits. It'll also help your local development workflow. Depending on which web framework you're using, it may make it a lot easier. And in general, it'll make everything, I think, smoother in terms of you learning how to push things into production, because that's where, when you're new to web development, um, it gets complicated right out of the gate when you want to go to production with a web app, right? So the other thing is you'll learn in the course is something called Docker Compose that will make your local development so much easier, because as you've probably learned as a front-end, back-end developer, getting all those tools right on your local system can be really complicated, and you have to learn a bunch of other things just to do web development nowadays. And Docker with Compose can make that really, really easy. Also, check... there's cards that you can use. I don't know how to use these in all changes saved. I don't know how to use cards in YouTube, and I need to figure out how to use these. So I've put these cards in here, and I don't know how to make them show up. Anyway, I don't know what I'm doing. So for Docker Compose, I actually have a couple of videos in this channel. One of them, several of them, they're under the Brett Talking Docker playlist. And when you do that, go through that list and look for things talking about Docker Compose, because I have a couple of videos in there showing off the basics of Compose. But you're going to get all that in the course, so you might as well just take the course and learn Compose that way. Thanks, Bill. Yes, that is my dog Lilu. Someone painted a photo of her, and that was pretty cool. And my wife gave it to me as a gift. Thank you. Oh, the chat keeps moving on me. Rue Player, thank you for loving the course. Hello, Pavan or Pavan. Hi, I'm beginner in Docker. My question is, Docker data volume and bind mounting looks the same when you look from the Docker host. What is the main difference in using? And so the main difference is whether or not you want Docker to manage your data for you. A bind mount means is usually, I use bind mounts mostly just for local development, so that when I have a local repo on my Mac or my Windows machine that I want to edit, but I want it to run inside a container, the bind mount connects the two, so that my host, I can edit the data and it's automatically updated in the container. There is no, at the low level of the operating system, there's really not any functional difference, because they're essentially using raw disk on the file system itself. Volumes allow Docker to manage the data volumes for you, which is a benefit in production and on servers. You want it to manage that stuff. And you can use volume drivers with that, where you don't get to use volume drivers in bind mounts. So I typically only recommend bind mounts for local development, and only when you must do that in production. Hello from India. Hello. All the examples you have used in the course, you used Nginx and MySQL. Both containers were running a small Linux, so host machine is running. Both containers were running a small Linux, so host machine is running basically two big processes for them. I think you're asking a question about how Docker runs applications on the host, and I tried to explain that in one of the Docker videos around the difference between containers and VMs. But essentially, a container is just a process running on the host, right? So a container is just the operating system putting some security boundaries and management stuff around an application. So that application to the host processor is just a regular application. There's no real overhead on it in terms of the processor. It, by default, an application you run in Docker will have access to all memory and all CPU and all I/O, that just like a regular application that's not running in a container. And then if you decide later that you want to put restrictions around that, you can. You can lock down so that maybe the container only runs on one CPU and only gets 1 gig of RAM. But by default, it's going to have access, just like any regular program, to all the resources of a computer. And obviously, if you're going to run a lot of containers in a server, you're going to want to lock all those down and limit their resources so they don't stomp on each other, and especially databases, which will use up all your RAM and kill your server. So you always want to limit the resources on those in production, just like you would on a real server that you were running databases on in production. So, in fact, in that case, if you're used to managing VMs, right, when you create VMs, you give them a certain amount of RAM, a certain amount of CPUs. when you go to servers with containers, think of them the same way. Each container, I need to give it a certain amount of RAM, certain amount of CPU, and that way you limit its ability to use and abuse the whole system. That way your containers all play together nicely in that way. So, hello from Japan. Can you please explain overlay networking and what it's used for? Is there a way to see traffic? I see the real traffic actually using a separate interface. So overlay networking is, okay, so in regular Docker on your machine, it's using what's called bridge networking, which is kind of like just, I would say, a simple home network when compared to the internet. The bridge network in Docker is a fake network that uses obviously a private IP subnet, and then it NATs out to the real network on your host computer, whatever that is. And that's the bridge network. That's what allows you to have a bunch of different IPs for all the containers in the network, but you only have one host IP on the computer, right? Once you go to multi-server, like in Swarm, that's overlay is essentially a multi-host bridge network. It's one bridge network that all the hosts see and communicate over for each network you create. So if you created 5 Docker virtual networks in overlay, then you would have 5 networks that each host can see and access for the containers you put on that network. And they would all operate behind NAT on the host IPs of those servers. So is there a way to see the traffic? I would say yes. The way you would see traffic there is exactly the same way you would see traffic on a host operating system. You could use Wireshark, Netcat, any sort of networking tool to either attach to the virtual interface that Docker creates. In fact, if you're inside a Docker machine, you can do, if you're inside a Docker host, you can just list the interfaces and you will see the VEST, the virtual interfaces, just like you would see physical interfaces. And Docker creates a virtual interface for each container and each virtual IP for an overlay network and a swarm. So there's a lot of IPs and virtual network interfaces there that you can look at. Or you can just attach yourself to the host NIC and see all the traffic coming in and out of that NIC. So I would say that there's probably some specific Docker networking tools out there. A cool one you might check out is NetShoot. And I happen to have one. I stole it from actually a Docker employee. And all NetShoot is a list of Linux. It's a bunch of Linux tools that are bundled into one container for troubleshooting networking. And if you're, let me see if I can. Yeah, so NetShoot, basically, it's got a bunch of Linux performance and networking troubleshooting tools. These are not necessarily specific to containers. They're just tools that are in a container so that you can push them on a server, or you can pull them down as an image, run them, and it works. So it really is about how much you know about Linux networking. Obviously, on the Windows side, you would need to use Windows networking tools, but essentially, Docker container NICs are the same. Yes, and the real traffic uses a virtual network, and you can attach to those virtual interfaces or to the physical interfaces that they're going over. Hello from Italy. Gavin asks, we're using a Redis logging driver to push our logs to our Redis server, which then gets picked up by Logstash to push out to our ELK stack. Okay, not a question. But yeah, so exactly. You can use different logging drivers, and Logstash is really cool with the ELK stack. Logstash in that case is similar to FluentD, which acts as a little manager in the middle to process the logs and push them out. So yes. In fact, I've got in my Swarm course a upcoming whole section on logging and ELK and logging drivers right after we finish the Prometheus one, which we're hard at work right now. How can a rogue Docker container exploit a kernel vulnerability and enter another running container on the same host? Any example at hand? So, right. A kernel vulnerability that can be exploited by a container just means the same as any kernel vulnerability that you could exploit without containers, right? So last year, I think it was, we had Dirty Cow. So Dirty Cow was basically a kernel bug that you can expose inside the functionality of the container abstraction, which means that if you were able to deal with, and the cow is the copy on write functionality of a container, which gets into the whole how a container uses images and it writes layers on the file system. So, in other words, on a single host with a single kernel, if you are concerned about kernel level abstractions, in other words, if you're concerned with making sure that even if there was a kernel bug that this application couldn't go to some other application, then you're going to need to use sort of a one container per host model. Not a bad model. I mean, if you're that level of security and you're really concerned about your workloads, then I would use one container per VM. It's still a legitimate choice for deploying high security infrastructure. And for years and years and years, we've had vulnerabilities in the drivers of virtual machines, which allowed you to potentially access the real host operating system through a virtual machine emulation. So every layer of abstraction could potentially be broken, right? Containers is just another level of abstraction that allows you to divvy up the container landscape. So if you have a kernel bug, yes, but we've only had this. This is the only one that I know of. I'm not going to claim that I'm a security expert on containers and that I know every vulnerability over the course of time. There's obviously vulnerabilities that have happened in Docker code, in the kernel namespace and C groups of a kernel. I don't have an example, but read up on Dirty Cow. That's a real world example that actually happened in, actually it was 2016, that basically, and what's interesting about this is that if you were running Docker with user namespaces turned on, which is a functionality that I always advocate, that functionality was written to Docker's core OS user namespaces. One of the Docker captains, Phil Estes, actually created this code in the Docker engine that allows you with one little switch, basically, that you turn on in the engine when you do its config JSON for the host, and you can allow all of your containers to not run as root. So the host, if the kernel is, or I'm sorry, if your application is attacked inside a container and they gain access to the sort of root of your container, if they were to try to break out of that container, even if they were using Dirty Cow exploit in the kernel, they couldn't get access to other things because they would not have root once they got to the host. So if you're concerned about security and that level of stuff, I would always enable user namespaces. And the reason that's not on by default is that not everything works with user namespaces. In my experience, most things do, but it's not enabled because it could break stuff. And secondly, use custom AppArmor profiles, use custom security profiles for your kernel. There's SE Linux. There's all these default security tools inside the Docker engine that you can enable. In fact, if you go and check out on my Ask Me Anything, which I have a list, github.com, Brett Fisher, AMA. In here, this is sort of literally another Ask Me Anything that I think there's security. If we look for security, there's one in here. What security concerns should I go through? I know this is a really long answer to your question, but I'm obviously I'm a fan of security, passionate about security. So in this right here, issue 17, and I will put this in the chat. I would generally go through these steps in order when I lock down my container infrastructure. I would say I'm still an amateur when it comes to security in this area, but I've been doing sysadmin for decades, and I've learned a thing or two. And so I typically go from the easiest with the biggest wins to the most complicated, most unlikely wins, right? So I don't go and implement, for example, like content trust, signing your code. The reason I don't recommend that up front is usually for a team to implement that is a lot of cost, it's a lot of effort, and it requires a whole team to change the way that they do everything, really. Um, but something like enabling user namespaces only requires a change once on each host, and then you got to test your containers once to make sure they work, and then you're done. There's no changing of your team. There's no changing of the processes. It's really just flipping a bit on a server. So, and in this case, with the dirty cow exploit, user namespaces would have prevented that from actually happening. So I tend to recommend things in an order of easy to implement. So hopefully that gets you started. All right. I lost my place. Can we build a .NET app container? Most of the examples I came across are PHP and Java apps. Absolutely, great question. I'm going to have more Windows and .NET stuff coming to either the Docker Mastery course or possibly its own course. I have, if you go in this YouTube channel, actually no, it's not in this YouTube channel. Where is it? I just made some slides. Okay. Long answer is I have slides. I don't think they're public or in a way that you can easily digest them yet, but I will be updating them in the course sometime this year. I think in Docker Mastery, just to give you a little touch, a little taste of .NET. But if you look up Windows containers, then you will find .NET apps. So on GitHub, on the Docker Hub, let's go to Docker Hub. I'm just going to wing it. You can look up and you'll find Microsoft has a .NET repo where they have they have two things. .NET Core, which that's what this is, which is the new sort of multi-OS open source version of .NET, and then there's sort of what I guess you'd maybe call the legacy .NET or the .NET Full, and those are all available here as well. Some of these, obviously the .NET traditional stuff like .NET 4 only runs on Windows. So you can find examples of that in Microsoft. By the way, if you go in here, Microsoft has tons of help links. So if I just went into ASP, no, that's .NET Core, ASP.NET. So ASP.NET image is the full ASP.NET, not just Core. And they have tons of links here to examples on how to build them, to how to run them, all that stuff. And these would be all running on Microsoft. So it would be using a very specific Microsoft image that would run on Windows Server 2016 or on Windows 10 Pro or Enterprise. And yes, I do know people that run those. Most of those examples came out after my course launched, so that's why I need to do an update on it to have some of that Windows stuff in there. Will you do lessons with real projects, for example, using Docker to increase the power of MySQL? So, Alex, I would argue that my courses are nothing but real projects. I mean, you're using real MySQL, you're using real Apache, you're using real Nginx, you're deploying Jenkins. I mean, you're deploying, a Jekyll server, you're deploying a Drupal server. So, I'm not sure what you mean by real projects. Obviously, I could always have more examples and more complicated examples, but to increase the power of MySQL, I'm not sure what that really means. So MySQL functions the same way in a container as it functions without a container. It's easier to deploy, easier to update, easier to maintain in a container. So you can have a 64-core server with 128 gig of RAM running MySQL or running MySQL in a container. The same way you would run MySQL there fundamentally is the same way that you would run it on a physical server. It's not going to change much. If you're really worried about I/O performance and how that functions across many different VMs and many different servers, you could go looking at hardware benchmarks and compare whether or not you want to run things in a VM or on bare metal. If you care about that, you could go to brettfisher.com/docker. And listed there under sample projects and tools is a Docker and HPE white paper, which I co-wrote. And I did all the performance testing on that. It's a little dated, but I don't think fundamentally the performance has changed any. It's a year and a half old. There's also, I think, another one there. There's a repo, in fact, of things that you can run on MySQL. These are really not anything specific to Docker, though. These are really just learning how to run performance testing on an application and then just comparing it on a VM or inside a container or on bare metal, you know, sort of taking your pick there. I, if you're going to do a MySQL cluster, that doesn't really change in a container either, because a cluster, a Docker or container solutions don't solve your clustering problem. You have to run clustering or mirroring or whatever the technology is uh, in the application itself. You can't run that necessarily on a Swarm or Kubernetes aren't going to just magically run a MySQL cluster for you. So you're going to need to set that up yourself. If you're asking me more about like MySQL clustering and how to set that up in a container, I'm not going to be the expert in that, but it's not a bad idea to throw in sort of clustering setup. Maybe I'll throw that in a more production-y talk or maybe in a future video on YouTube. So that's a good idea. Adam asks, when setting up a LAMP stack using Docker, I usually run into errors installing packages. How do you find appropriate packages for any particular setup? So, Adam, what I normally do is when I'm testing out, basically you're asking how to build a Docker file, right? So, because that's where you're going to be running all your scripts. So if I'm running a Docker file, then I'm going to probably jump into a container with bash and run those commands one by one in the container. So if I'm building it on Ubuntu, let's say I'm going to build, let's just say a PHP app. So I'm going to just pull PHP real quick, make sure I have PHP at all. So if I'm going to build a custom PHP app and I need to figure out which of those run commands and stuff I need to use, then I would probably do a Docker run with an IT of PHP and just shell into it. And then I would do like my apt get update, and I would manually work through each command I'm going to put in a run command, making sure each one of those works interactively. And then if they work interactively, they should be able to work just fine in run commands. Usually Docker is going to output any errors during the build process, so it's going to tell me exactly what the error is, if the application couldn't install or couldn't run something. And then if I'm having a problem with my CMD because maybe the CMD or the entry point aren't correct, then I would again jump in. If I built an image that just doesn't launch correctly, I would use that custom image and jump into it directly. So I would just, Docker run that custom image, so custom image, whatever it was that I built, and then I would get a shell in it, and that would replace whatever the command was that I was trying to run, and then I would run what I'm trying to run in the command and see if that executes properly. Because when I jump into that shell, a lot of things are going to happen. Of course, I don't have that custom image, but if I was to jump into the SH, into the PHP, PHP is going to dump me somewhere in a specific. So like it dumps me in the root of the operating system. So maybe I shouldn't be in that directory. I need to change my working directory, for example. So if I had to run like PHP something something, then if that command doesn't work right here, then it's not going to work in the Docker file. So that helps me work through my process of getting the Docker file into shape. So hopefully that gets you started. But yeah, that's the thing. I mean, with Docker files, it's usually me editing a Docker file, saving it, rerunning the build. It gives me an error. I look at the error. I jump back in the Docker file, try something different. But I also jump into these. By the way, pro tip on this, if you fail a Docker image build, and so let's say I do, I don't have a good example off the top of my head. If I had a bad Docker file that had an error, let me actually just see if I can create this example on the fly. I just realized I'm not showing my screen. Let me show my screen now. Yeah. All right. Sorry about that. This is the first time I've been doing the Q&A, so it is an amateur hour. So let's do CD. Let's make a tempered Docker. Okay, so Docker file. Actually, so I'm going to do this. And this is going to build, but it's going to fail on one of the commands, right? So it's going to build and succeed on the first build step and the second build step, but then it's going to get to the third build step and error out and crash, right? So it just says blah, not found, right? Well, maybe I'm not exactly sure what that command is and how to use it. So what I can do, though, is I can do a Docker run from that specific ID of the step right before the step that failed. So if I did this, I think this will work. Oops, no, it's not that. Sorry. Oops. It's not that ID. Docker image ls. Okay, Docker. All right, the last image. All right, see this one right here? This last image built is the ID of the failed image that we just tried to build. So what I really want to do is instead of that, I want to do this. So I'm copying in the image ID of that unnamed image that was unsuccessfully built. And if I do that, okay, if I do that, I'm getting the image at the last state right before it aired out, which means if I have a really complicated Docker file and I've got 100 lines in it or something, I can run that image at the last time it was successful. So I'm getting it right before the error, which means it will have everything in it except for that last step in the error. And then I can try to run that command like blah. And obviously it's not found because it's not a real command. So that's how I can troubleshoot right there based on the last level. It took me forever to figure this out, and obviously I don't use it a lot because you can tell I didn't know that you can't use the cache hash. You have to actually use the image hash. And the way you get that is just remember you can do it. Oops, let me exit. You just do a Docker image ls, and it'll be the one at the top, or it should be. Is it images? I thought it was -l. Why am I thinking? There's like, maybe that's the Docker ps command. Maybe that's what it is. Yeah. So I thought on images -l would also give you the same thing as a ps, but it doesn't. -l means the latest, the last one you just ran. But it doesn't work like that on images, so I thought it did. Hopefully that'll get you started. And that's actually a great topic for another Docker video, is to talk about how to troubleshoot failed Docker builds. So that's a good question. All right. Is your Udemy course good enough to pass or prep the DCA? So thank you for that question. The DCA, Docker Certified Associate, Docker Certified Associate. I was lucky enough to be one of the beta testers, and luckily I passed that exam. The DCA is more than just learning the Docker open source. It is also knowing Docker Enterprise Edition, the paid product, really well. That's actually what it's about. Docker DCA is specifically for Docker's paid product. My course does not cover the paid product. However, it probably gets you over 50% of the way there. If you look at the bottom of the course, in the last section, there's an article that says, is this course going to get me through the DCA or something like that? So you can go read that in the last section of the course. It'll give you all the tips on what the DCA is about, how to pass it, how to study for it, and then how much of my course is in it. I'd say it'd get you probably half the way there, but you're going to have to get if you don't have Docker Enterprise Edition, you're going to have to get a trial license that lasts 30 days and run that and go through all the learning of Docker EE that I don't actually teach. So there's actually, I believe, a book by Nigel Poulton that will go through that. He has a book that claims to get you, I haven't read it, but he's a smart guy. He's another Docker captain. So there's a Docker book that he made on getting certified or getting the DCA certification. So I would say finish my course and then read his book, and his book will probably get you through the EE components. What I just did was I basically went through Docker's prep guide, and each one that it said, you should be able to do this thing and then do this thing, and I just made sure that I could do that from memory. And once I got through every one of them and I could do each one of those things from memory without looking up on the internet, because during the course you can't, or during the test, you can't look it up on the internet. So good luck with the DCA though. Which orchestration do I prefer? I prefer Swarm, but honestly, for anyone, I prefer the one that works best for you. So Obviously, we've got lots of choices now. We've got Azure Fabric. We've got obviously Kubernetes, which is very popular. But now Kubernetes is at least a dozen different ways to do it. You can do it with Rancher. You can do it with Docker EE. You can do it with AKS, AWS Kubernetes. Was it EKS? Sorry, EKS, Fargate, all those things. Then you have Mesos DCOS, stuff like that. I prefer the one that is the easiest, which I think is Swarm. But depending on your requirements in your team, you're going to need to try out some of them. And so I usually try to get people started with Swarm because they can learn that in a day. It's really easy to get the basics of it and the gist of how it works. And it uses compose files that you already know from using it locally. Then once you jump to any of the other orchestrators, you've got a lot more components to learn, different files and YAML formats and things that aren't really comparable to local Docker experiences. So I tend to start with Swarm because it gets you through the concepts of an orchestrator and Raft consensus algorithms and all that stuff. And then people can hop to other orchestrators like Kubernetes and stuff like that to learn whether they need that or not. Since the Swarm is the simplest to use, I typically recommend that. And if people can't get what they need to do with Swarm, then that's when I would recommend jumping to another solution. But it's very individual. It's very specific to the team and your workloads and your requirements. So, a few minutes left on this AMA, and then we will have another one next week. So sorry if I don't get through all the questions. We've had lots of questions. That's been great. Beginning with Docker. Docker for containers is what JVM is for Java. Is this analogy correct? Docker job is to convert machine instructions so that the host and containers can understand each other. Doesn't matter what host is. No, I would say that is probably not a good analogy, just because Docker doesn't do any abstraction. Docker simply will take the application and run it on the host kernel. It does not perform any sort of middle layer compilation. If you're on a Windows kernel, you have to have a Windows binary in the container. If you're on a Linux kernel, you have to have a Linux binary in the container. If you're on Raspberry Pi or a mainframe or i386 or a PPC processor, all those things would mean that the image you're running has to be built for that OS kernel. So it doesn't add that level of abstraction like that. It's going to basically manage the security and the boundaries around your application so that it's restricted, but it's not going to perform any sort, because if it did perform that level of abstraction, we would have a performance hit, and you really don't want that. So Docker's job is not to make sure that your SQL.exe on Windows runs on Linux, because that won't work. Its job is to make sure that Linux apps run limited and constrained and in that little package format on Linux, and that Windows containers running Windows binaries run well on a Windows kernel. So hopefully people use the VM analogy, but that also kind of falls down because it's not running a VM. There's not multi-kernels here. We're just talking about many applications running on the same kernel that were built for that kernel. So hope that helps clear that up. But it's a good question. It sometimes is hard. It took me a while, in fact, to figure out what Docker was really doing in the background, and it's not doing any sort of compilation or layer in the middle like that. Kernel Panic. That's a good name. Hello from Argentina. Thanks. Jeff asked, on a Mac, I've got 40 sites running, built-in LAMP stack for dev. Want to switch to Docker, currently using Etsy host for fully. How can I manage ports to fully qualified domain names, Jeff? Great question. I would say you won't be using fully qualified domain names. What you'll do is, if you're taking the course, you will learn through the networking and the compose parts how to take many different containers that are off of many different images, and then run those with a single command, or run those inside a single network where they all find each other. I explain all that through. It doesn't change the fact that you have 40 sites. In a LAMP stack. If you have 40 websites, you simply are going to make compose files in YAML that have your database and then your LAMP. So a PHP app is going to run in the front, and a MySQL is going to be running in the back, and you're going to put those in a compose file and then run the compose file, and they will all find each other on the network based on their service name, which is similar to a host name. It is not a fully qualified domain name. So if you need, once you get through the course, try to make your apps work in the way the course tells you, because that's sort of the easiest and best way. If you need to do something like a reverse proxy that looks at the incoming host and then it routes around to based on that host name, that's a totally normal thing. I would look up something like traffic reverse proxy, and the traffic reverse proxy or Docker flow proxy, which is another one. These both work with Swarm as well as just with Docker or Kubernetes for traffic purposes. Traffic basically works across just about any, even not non-container workloads, but it will act as a reverse proxy, and kind of like Nginx or HA proxy or other things, it will look at incoming traffic and route things around different containers based on hostname. And if you want an example of that on Swarm, you can look at my repo, Brett Fisher, dog versus cat. And dog versus cat is something that I've been building this year. It's not completely finished, but it shows you examples of using compose files. For example, this is a Ghost app, so it runs runs Node, but similar to PHP, right? And it's a single compose file that has the Node.js front end, and then it has a database back end, and it uses these little labels to tell the proxy on the front end how to route traffic around the network. So that's how you could have basically a set of servers with one published port, like 443 and port 80, running 40 different websites. You could do it that way. So hopefully that helps. Although Docker is not meant for this use case, but can run full-blown graphical applications. So good question, Harjeet, how you say your name? Good question. So Docker is not necessarily designed to run IDEs. So anything graphical out of the box, Docker's not going to use. Docker's not going to work with. You can do that if you're a Linuxy person and you know how Xorg and the way that Linux subsystems do graphics through sort of a network port. You can do that with Docker. It gets pretty advanced pretty quickly, so you really have to know system internals. So it could technically display something on your screen through Xorg. You can get that to work on Mac. I'm assuming you can get that to work on Windows, but that's not really its sweet spot. That it would get very complicated very quickly, and of course it would have to be an application that is built for Linux, right? So most GUI applications for Mac and Windows are not built for Linux. I don't know if IntelliJ does have a Linux version. So it's possible, just not likely or easy to do. In fact, I think on the Windows container side, if you're using Windows binaries, Microsoft doesn't even ship the RDP components for graphical remote display. They don't even ship those in the images. So there's no way to use like an RDP server, for example, on the Windows side. Hey, Brett, how are you nowadays? Every app I must build, I have a Docker file within. How do you live without this amazing tool so far? So, Rodrigo, I don't. I use Docker files every day. I don't know how we ever lived without them. So yeah, I gotten rid of a lot of scripts by using Docker files and saved myself a lot of headaches. All right, so 2 more questions. I'll do 2 more questions. I'm forced to bundle my war into a DB bundle framework. Oh, okay, this is replying to the previous question. So this is a question on volumes. If data in volumes do not need to be shared amongst containers, then you should have 1 volume per container, right? There's no reason to map multiple containers to the same volume if they don't need to share data. So otherwise, that just gets really complicated, and then you could potentially have some sort of corruption if each one possibly was going to overwrite anything else. So database redundancies from Mohammed, the question about multiple replicas of MySQL replicas. So again, Swarm and Kubernetes do not create database replicas or database clusters or database mirroring, whatever you want to call it. You have to do that in the apps themselves. And if you just kind of Google around, you will eventually find some examples. There's one called Autopilot. I think it's autopilot.io. Yeah, so autopilot.io has some examples of how to do automated cluster setup inside of containers. Basically, what you're doing is you're writing scripts to tell your databases when they start up the first time to self-organize. And that's not an easy thing to do with legacy database technologies like MySQL or Postgres. You can find Percona has some Docker images that maybe would help set that up. So Docker database cluster Postgres. So random Googling, and you're going to, right off the bat, I'm going to find recipes for creating Postgres clusters with Docker Swarm using Docker 112. So those would be ways I would go down. They're going to be different based on what orchestrator you're using, how your clusters are set up. So you're going to have to sort of work your way through that. There is no one-size-fits-all way to deploy a database cluster, unfortunately. But that's not something that your Docker or your Swarm or your Kubernetes is going to do for you automatically. It's still something at the application level that you have to do, just like with MongoDB or Elasticsearch or Redis or anything. Any of those persistent data stores that need to talk to each other, you have to design them to be able to find each other. Or just, if you want to do it old school way, just deploy the containers on your server if it's a really simple, small setup. And then once they're running in the containers, manually set up the cluster. But the problem is, as soon as you lose that container, you would have to redo the cluster setup because it wouldn't be automatic. So it's not for the faint of heart. It's kind of a hard thing to do to make it completely automated and always failing and always being able to recover. So that's just a problem with old database technologies. If you kind of search around, you might find new database technologies that you can do that are more designed for clusters. And basically, it's not so much about containers. It's more about dynamic infrastructure and distributed computing. So let's see, if I looked up, there's one called Cockroach Labs. Here, I'll pull up these for Windows for you. There's one under Cockroach Labs called CockroachDB. There's an open source one known as Vitness. I think is how you say it, VITESS, Vitis. I don't even know how to say it. And then RethinkDB is another one where they're either a brand new type of orchestrator for databases, not orchestrator, it's the wrong word. They're a brand new type of database technology, or in the case of some of these, they are using old school like MySQL, and they're sort of making it work better in a distributed dynamic computing model. So you might want to check those out if you're deploying applications on your own and you're deploying custom applications that you can control the database technology. Definitely look at those first instead of looking at traditional stuff like just traditional MySQL or Postgres. Yeah. Can we have NAS storage? Okay, this is the last question. Actually, I might have skipped one. I have a Docker file which builds fine on one system but fails. npm not found on another system. Both have the same architecture but different kernels and OS. Well, that's why, actually, is if you have different kernels and OSs, they will not run. So you can't run, if you've built an image for Linux, you can't run it on a Raspberry Pi, on ARM, for example. You would have to build a specific image for that kernel because each kernel is going to run different applications, and Docker does not solve that problem. Docker does not make Raspberry Pi app run on Windows or on Windows container. Now, that gets a little weird because when you're using Docker for Mac or Docker for Windows, Docker is running Linux containers in the background, and it also has this feature where it will emulate things like ARM or PPC. So it may seem like things are running, but that's not really the case. It's a little bit of voodoo. So especially on the Windows side, where you can choose Windows containers or Linux containers, that can get a little hairy as well. But in essence, Docker does not provide multi-architecture, emulation for you out of the box. If you deploy a Windows Server 2016, it's got to be a Windows binary. If you're going to run it natively on an ARM, like a Raspberry Pi or something, you have to build an ARM-based image for that. So that might be your issue. The only other issue I would say that's probably common is if you're using Compose with Node and you're using local development with Compose and you're doing bind mounts, then you might be bind mounting NPM stuff into a container, and on the host you're running Windows or Mac, and then in the container you're running Linux, and NPM has incompatible binaries. For that case, that's a larger discussion, but really you need to look at how your NPM works and your Node project. If you look up my Node example project, for example, on GitHub, this example project will help you avoid that if you're having that sort of issue for bind mounting and local development for Node. I also plan on putting out a lot more Node stuff later this year, so stay tuned for an announcement on Docker with Node.js for that. So, all right, true, last question. Can we have NAS storage mounting inside containers? Yes, NAS storage, you can mount it inside containers, although really it's probably better that you use volume drivers that manage that connection for you. I have seen people that run the actual mount commands inside the container. The problem with that is that you're now giving, if there's an app inside that container itself now has to have permissions to go and mount the drive. So it has to have whatever it needs to have, the password, the secret, whatever it needs to get to that NAS. It's now in the container, so potentially if someone hacked into that container, they could get that stuff. So I don't like to do that. Plus, if I'm doing it in the container versus outside the container, then inside the container, I have to put the components to be able to mount NFS drives, and those aren't built into containers by default, so that gets harder. You can totally do it, though. It's just not easy to do out of the box. What I recommend is that you use volume drivers, and you can just probably Google around and find lots of examples of how people use volume drivers, even the default local driver, to mount NAS storage right when the container starts up, and it's outside of the container so that Docker is managing it for you, and that works as well. Well, thank you everybody for coming. I'm glad to have another Q&A, and I will be doing these every week, and you can just